Arby's, we have the meats. Hey, it's lesson 6-3, so we're on lesson 6, day 3, and our learning targets are going to continue to be A, to identify functions, and 2, to use functions and input values to find output values. So that picture to the right, yep, that's the exact patty maker that I used when I worked at a grocery store in high school and college. And it is a function. It's a great example. You input a bunch of ground beef and the output is patties. That's it. Doesn't come out with anything else. It's a function because for one input you'll get one output. Okay? Remember, for functions, if you put in one thing and you get more than one output, then it's not a function anymore. So we're going to work with that today. And why don't you open up your notes book to, I believe it is page 60, and we are at number 11. We're going to go through a few examples working with functions today. All right, so please take notes as we go. All right, let's look at number 11. It says use a diagram to represent a function. Put these numbers in the ovals to show ordered pairs that form a function. So we're given all these, and we have formed a function. And if you don't recall, these are called a mapping diagram. I've mentioned this before. This is a mapping diagram. And so we're going to take those examples, those values, and put them in here so that we have inputs and outputs so that every input has one output. So, for example, right now the -4, 3, -3, so -4 is used, -3, 1, 2, and 5 are all used in the input. So we're left with 5 outputs. We got to put them in there so that each input has only one output. So we could say 1 goes to, well, 1 could go to -3. 2 could go to, oh no, I already used negative, they already used -3. My mistake. We already used these two as well, so we could go 5, 6, 7. And we're going to map the 1 to the 5, so that would be one ordered pair, 2 to the 6, and 5 to the 7. So in this case, every input, so -4 only has one output. -3 only goes to one output, and so on. So that is a function. It says in the blank diagram, use the same numbers to show a different set of ordered pairs that forms a different function. Okay? Whoa, that word function got a little messed up there. But let's use them differently to form a different function. You know what? I'm going to make an example of a non-function instead. I think those will be good to see side to side. I'm going to also fix this. Not sure what happened there. So this is going to be a non-function. I'm going to use red here. So let's just say we have, let's just use all our positive values. Let's use 1, 2, 5, 5, 6. Let's do that. 1, 2, 5, 5, 6. Now let's say 1. If you input 1, you get out -4. Good. That's so far it's a function because one input goes to one output. If you input 2, let's say you get out -3. Still 1 to 1. It's still a function. Let's do, if you input 5, you get out -3. Okay, it's still one input to one output. If you input 5, let's say you get out -1. Now that right there is where it's not a function anymore. And I'll show you why once I put this last value in. If you put 6, you get out 7. So if you take if you input 5, in this case it says you get out -3. But in this case it says you get out -1. So because your input is 5, it says your output could be -3 or -1. That is 2 outputs for the same input, and that would be a non-function. All right, let's go to number 12. A bag includes one number card for each of the numbers 1 through 25. Each of 25 students randomly selects a number card from the bag. Terry says that if the number is the input and the student is the output, the relationship is a function. Mario says that if the student is the input and the number is the output, the relationship is a function. Who is correct? Well, there's one number card, each 1 through 25. So, for instance, 1, 2, 3, 4, and so on. And there are 25 students. Exactly. So you could say we have Mario, we have Carrie. Let's just make up some names here. Let's do TJ, RJ. Say 5 goes to PJ. I'm just coming up with names that are really short. But the point is, every number could go to one different student because there's 25 numbers and 25 students. And each number goes to one student, so they're all going to have, it's all going to be 1-to-1. Now, if you reversed it and you said, well, that's what Carrie's saying. Let's say the names go to the numbers. Let's just say Mario is the input and output would be 1. Let's say Carrie is the input and the output is 2. TJ, output is 3, and so on. Because there's 25 of one thing and 25 to the other thing, and it says every student randomly selects a number from the bag, unless they would put it back, they're all going to have just one output, and vice versa. Every number would go to one student. So in this case, we can say they're both correct. And I'm going to type that in here. You can write that in there. They are both correct. And again, our reasoning would be because it is always 1-to-1 when there are no repeats of input or output values. So if there's never any repeats, if one kid gets a number and one number goes to one kid, there's never going to be any repeats, so there's no way that it couldn't be a function. All right, next one, let's go to number 13. Let's look at this data. It says each molecule of water contains 2 hydrogen and 1 oxygen. So if you've ever seen the, it's called H2O, 2 hydrogen, 1 oxygen. You'll learn that in science. Complete the table. Is the number of hydrogen atoms a function of the number of oxygen atoms? Explain. So let's fill in the table first. So if you have 1 oxygen, there's always 2 hydrogen. Okay, so in other words, it's always times 2. So there's twice as many hydrogen as oxygen. So if it's 2, it'd be 4. If it's 3, it'd be 6. 4 would be 8, and so on. So we can actually say if we have, this is our O and this is our H, we could say H is equal to 2 times O. That's not a 0, by the way. So it says, is it a function? Well, is it a function? Is it always 1-to-1? If you input 1 here, you get out 2. If you put 2, you get 4. 3, you get 6. 4, you get 8. There's no repeats. It'll always be a function because it's always 1-to-1. All right. We got one more example here. It's on the next page, on page 61, I believe. There's multiple parts to it, but let's take a look. It says Sean and Rachel were both born on April 17th. When Sean was 4, his sister Rachel was 2. Okay? Write an equation that can be used to determine Rachel's age given Sean's age. Write an equation that can be used to determine Sean's age given Rachel's age. So let's say Rachel is R, Sean is S. So when Sean was 4, Rachel was 2. So Sean's age is equal to, I know in this case it looks like it's 2 times Rachel's age. But if we add a year, It's not going to be 2 times it. It's just going to be always 2 years more. So let's say it's going to be Rachel's plus 2. If you add 2 to Rachel's, you'll get Sean's. Now, if you reverse it, you want Sean's age, or sorry, Rachel's age. Rachel's always 2 less than Sean, 2 years younger. So you take Sean and you subtract 2. So there's some equations that you can use for this situation, because they're always 2 years apart. Now, let's make Sean's age the input. So that's when we would be using this one. So that would be the equation Rachel is equal to Sean minus 2. So if Sean's age is 11, plug in 11 for S and subtract 2, you get 9. Do that every time you subtract 2, you'll see there's a pattern. And the reverse would be if you have Sean's age is our output, that's going to be equal to Rachel plus 2. So I add 2 every time. So I get 3, 4, 5, and so on. Now, part C says describe the relationships in the tables. Is either relationship a function? Explain. Well, it's described in what they are. Rachel is always 2 years younger, Rachel is always 2 years younger than Sean. I'm going to type this one again. So that's one of them. And if you look at the reverse, Sean is always 2 years older than Rachel. Now are they functions or not? Is it 1 to 1? If you input one thing, do you get one thing out? According to this, every time there's an input, there is an output. It is a function because it is always 1 to 1. Functions 1 to 1. Now, last part D. The problem states that Sean was 4, Rachel is 2. Sean's age is twice Rachel's age. Can this also be a rule for the relationship between their ages? Why or why not? So the question is, could Sean always equal 2 times Rachel? Well, in this case, if you plug them in, it works. But let's say when Sean is 5, Rachel would be 1 year older as well. She would be 3. So does that work? Can you plug in and get 5 equals 2 times 3? Nope, that doesn't work because that would be 5 equals 6. That's not true. So it cannot be a rule in general. A general rule. For that very reason. All right, that's all we're going to talk about for today for functions. Again, we're just looking at are things functions or not, and how can we deal with equations of functions to find output values. All right, that's lesson 6.3. Enjoy your day.